Let us see about classification of signals. Now, on completion of the course, the students can classify the continuous time signal based on properties, and also they can classify the discrete time signal based on properties. Now, what is meant by continuous time and discrete time signal? Continuous time signal, a signal that is defined for every instant of time, is known as continuous time signal. Continuous time signals are continuous in amplitude and continuous in time. It is denoted by x of t, and it is shown in the figure. That is, the example is sine wave. Discrete time signal, a signal that is defined for discrete instant of time, is known as the discrete time signal. Discrete time signals are continuous in amplitude and discrete in time. It is also obtained by sampling a continuous time signal. It is denoted by x of n, and it is shown in figure. This is the example for the discrete time signal. Now we can see the classification of continuous time and discrete time signal. That is a major classification. It is classified into deterministic and random signal, periodic and aperiodic signal, even and odd signal, energy and power signal, causal and non-causal signals. Now we can see one by one. Deterministic and random signal. What is deterministic signal? A signal is said to be deterministic if there is no uncertainty over the signal at any instant of time. That is, its instantaneous value can be predicted. That is, it can be represented by mathematical equation. For example, the sine wave. That is the deterministic signal. Random signal, or otherwise said to be non-deterministic signal. A signal is said to be random if there is an uncertainty over the signal at any instant of time. That is, its instantaneously value can be predicted. It cannot be represented by mathematical equation. Example, the noise signal. Periodic and aperiodic signal. Periodic signal. A signal is said to be periodic if it repeats again and again over a certain period of time. A periodic signal, a signal that does not repeat at a defined interval of time, is said to be a periodic signal. And continuous domain. In continuous domain, a continuous time signal is said to be periodic if it satisfies the condition x of t equal to x of t plus capital T, where capital T is the fundamental time period, and if the above condition is not satisfied, then the signal is said to be aperiodic, and the fundamental time period capital T equal to 2 pi by omega, where omega is the fundamental angular frequency in radian per second. And deterministic signal, in deterministic time signal, it's said to be periodic if it is satisfies the condition x of n equal to x of n plus capital N, where n is the fundamental time period, and if the above condition is not satisfied, then the signal is said to be aperiodic, and the fundamental time period capital N equal to 2 pi m by omega, where omega is the fundamental and angular frequency in radian per second, and m is the smallest positive integer, that makes n is the positive integer. Next one is even and odd signal, otherwise it is said to be symmetric and antisymmetric signal. That is, in continuous domain, the even signal, that is a signal that exhibits symmetry with respect to t equal to 0, is called the even signal. Even signal satisfies the condition x of t equal to x of minus t. Example, x of t equal to a cos t. An odd signal, a signal that exhibits antisymmetry with respect to t equal to 0, is said to be odd signal. Odd signal satisfies the condition x of t equal to minus of x of minus t. For example, x of t equal to a sin t. And the even part, that is, any signal can be divided into even and odd signal. That is, the even and components can be represented as x of t is x e of t equal to 1 by 2 pi x of t plus x of minus t, and the odd component is given as x odd of t equal to 1 by 2 into x of t minus x of minus t. In the case of discrete time, the even signal that exhibits, the even signals can be denoted as that exhibits symmetry with respect to n equal to 0, is called to the even signal. Even signal satisfies the condition x of n equal to n x of minus n, and the odd signal that exhibits the antisymmetric with respect to n equal to 0 is called the odd signal. Odd signal satisfies the condition x of n equal to minus x of minus n, and it is again divided into even and odd component, and the even component is said to be x e of n equal to 1 by 2 x of n plus x of minus n, and the odd component is given as x odd of n equal to 1 by 2 into x of n minus x of minus n. And next one is energy and power signal. The energy signal which has finite energy and zero average power is called the energy signal, and the non-periodic signal like exponential signal which has constant energy, and so non-periodic signals are energy signal. For example, the energy signal that is E lies in between 0 to infinity and P equal to 0. In the case of continuous time signal, the energy signal is given by this equation, and the discrete time signal it is given by the second equation. Power signal, the signal which has finite average power and infinite energy is called power signal. The periodic signal like sinusoidal complex exponential signal which have constant power, and so periodic signals are power signals. Therefore the power signal is it is varies from 0 to infinity and energy is infinite. In the case of continuous time signal, this is the equation for finding the power signal, and the case of discrete time signal, the second equation is used for finding the power. Next one is causal and non-causal signal. In the case of continuous domain, the causal signal is said to be causal if it defined for t greater than or equal to 0, that is x of t equal to 0 for t less than 0. Non-causal signal, a signal is said to be non-causal if it is defined for t less than 0 or for both t less than 0 and t greater than or equal to 0, that is x of t not equal to 0 for t less than 0. When a non-causal signal is defined only for t greater less than 0, it is said to be the anti-causal signal. And in the case of discrete domain, that is the causal signal, a signal is said to be causal if it is defined for n greater than or equal to 0, that is x of n equal to 0 for n less than 0, and non-causal, that is if for n less than 0 and for n less than or greater than or equal to 0, that is x of n not equal to 0 for n less than 0. And when a non-causal signal is defined only for n less than 0, it is said to be anti-causal signal. That's about the classification of signal. Now these are some of the quiz questions. Okay, thank you.